Today, lesson 4A, more ratio and proportional topics. We kind of hit on these basic ideas a couple of lessons ago, but today we're going to go into a little more depth on that. And this really is review from 7th grade. And so the standards, or not the standards, well, the standards, but also the objectives are similar to a couple of lessons ago. So I'll give you about a minute or so to get that copied down. All right, let's get started. Some background knowledge from 7th grade. A ratio is a comparison of two whole numbers by division. Some people like to think of a ratio as a fraction. I believe this entire definition is in your notes. Here are some examples of ratios: 4 boys to 9 girls. This is an example of a part-to-part ratio. There are a few ways of writing that ratio. Normally we write it as a fraction, but sometimes we use a colon. Sometimes we use the letter 2, or not the letter, the word 2 in between, and sometimes we say 4 out of 9. Those are all common ways of writing 4 boys to 9 girls as a ratio. Most of the time we write ratios as fractions, and then the second most common way is with a colon in between there. So the idea of a ratio is already written in your notes. The above ratio could also be thought of as 4 boys to 13 total students. In other words, if we added the 4 boys and 9 girls together, that's a representation of 13 students total. And so sometimes we change it up a little bit as far as that goes. And that's considered to be an example of part to whole. 13 whole number or total students altogether there. A rate is a ratio that compares two quantities that are measured in different units. That definition is also in your notes. We are interested in a specific kind of rate, and that is a unit rate. And a unit rate is a rate that compares quantities in different units and has a denominator that is 1. And typically to find a unit rate, we simply divide to simplify. Okay? Ratios don't write units. Rates and unit rates, we do write the units. And once again, this is all from 7th grade. So here's an example of a typical problem where you may be asked to find the unit rate. 1,575 words in 25 minutes. What we're trying to find, if we're finding the unit rate, is how many words per minute. And the way to figure that out, of course, is to divide. And once we do that division, we get 63 words per minute. Remember, in a unit rate and a rate, we need to make sure we write the units. Words per minute would be the units. Here's another example from last year. 426 miles on 12 gallons. If we're asked to find the unit rate, we're asked to find how many miles per gallon. We divide to find that, and in this case it would be 35.5 or 35.5 miles per gallon. And so actually these two are more like a 6th grade problem, simply because we're not dealing with any fractions yet. This is a problem from last year, so I would like everybody to try and find the unit rate for that one. Seb has a pet snail and entered the snail in a race. In the race, the winning snail traveled 4.5 millimeters in 3/4 of a minute. How fast was the snail traveling in millimeters per minute? In other words, you're asked to find the unit rate. If you had me last year, we did this problem. Go ahead and find the unit rate. We're asked to find out how fast the snail was traveling in millimeters per minute. That's a key indicator of which direction you need to do your division. Millimeters per minute is an example of unit rate, so we need to divide the millimeters and then divide that by the number of minutes. 4.5 millimeters divided by 3/4 of a minute. This would have been a typical unit rate problem you should have done last year, because the 7th grade standard is unit rates of decimals and fractions, and this involves both of them. So you could either turn 4.5 into 4.5 or turn 3/4 into a decimal. It doesn't matter. I'm going to go with 4.5 as 4.5. And so remember, to find the unit rate, you divide to simplify. So 4.5 divided by 3/4 is 9/2 divided by 3/4. And then when we do what we need to do mathematically, we should end up with 6 millimeters per minute. Any questions there? So that's from 7th grade. Now, if you were in honors last year, you probably did the next thing, and if you weren't, you probably did not. This is called rate conversions with unit analysis. Basically, what we're doing is we're taking one unit rate and we're changing it into another unit rate. So you need to make sure on all three of the problems we're doing in our notes here, if you didn't do this last year, you take very, very good notes. We're converting from 36 inches per second to feet per minute. So we're actually doing two conversions kind of at the same time there, if you want to think of it that way. So we're starting with 36 inches per second, and I'm writing it more like a normal fraction there. We're converting from 36 inches per 1 second or per second into feet per minute. Two conversions there. So the way that I like to deal with these is I like to take a look at both numerators first. I'm converting from inches to feet. What's the conversion from inches to feet? I mean, that's one everybody should know. How many inches in 1 foot? 12. Okay? So the rate there, the conversion from inches to feet, there are 12 inches in 1 foot. And once again, especially the first couple, you need to make sure you take very good notes. So the idea here is we need to get rid of the inches and have it turn into feet. That's why I'm starting with 36 inches per second, turning it into feet per minute, because that's what we're trying to convert to. So we're either going to multiply by 12 inches over 1 feet, or 1 foot, or we're going to multiply by 1 foot over 12 inches. One of those two. Now, the way to determine that is we need to get rid of inches so that we're left with feet. So let me show you something here. And this part you probably shouldn't write down. But if you thought it was this, that would not be the right thing, because the inches are not going to cancel out. And the thing you need to realize right here is we have a fraction times a fraction. And so what we would end up with there now would be inches squared over seconds feet, but that's not what we need to happen. So this is not what we would want to do. We would want to use the second fraction there. 1 foot over 12 inches. Now, when we do that, remember we have a fraction times a fraction. And when we're dealing with fractions, as far as multiplying, we can cross-divide. And then when we cross-divide units, the inches cancel each other out. Inches go into inches once and once. Now I'm going to take all of this writing off of here. And we've already decided that it is 1 foot over 12 inches because of the cancellation of the units. So when I do that, inches cancel out, and notice that I'm only left with feet on top, and that's what I need to happen. So we've dealt with the conversion of inches to feet. Now we have to deal with the conversion of seconds to minutes. What's the relationship between seconds and minutes? 60 seconds in a minute. So the question will be this. Are we going to multiply by 60 seconds over 1 minute, or are we going to multiply by 1 minute over 60 seconds? Which one of those rates? Well, we need to somehow get rid of seconds and be only left with minutes. That's what we need to happen. Anybody have any idea which one it would be? 60 seconds over 1 minute. And that's the one it would be, because that way, diagonally, the seconds will cancel out. As I'm trying to get caught up here, you can see right here that the seconds will cancel out, and you're left with feet on top and minutes on the bottom. Feet on top and minutes on the bottom, which is what we wanted right there. Now at this point, it's just 36 over 1 times 1 over 12 times 60 over 1. We just have 3 fractions that we're multiplying together. So we did some diagonal cross-canceling here and here with the units, but we can also do the same thing with the numbers. Anybody see some cross-canceling that we can do there? Yeah.
12 goes into 65 times.
Okay. So 12 goes into 12 once and 65 times. And that's it. If you're going to do that, that's all you can do. Because now we have On the bottom, we have 1 times 1 times 1, but on the top, we have 36 times 1 times 5. By the way, what is 36 times 1 times 5? What is that?
I'm sorry, I forgot. Oh,
180. 180. So that means when we did the conversion, it's 180 feet per minute. Now, for those of you who weren't in honors last year, this may seem a little confusing, but after we do a couple of problems, you will see that it will be all cleared up there. So let me take all my messy writing off there, and we end up with, and notice that I did the cross-canceling a little bit differently here. I went with 12 into 12 once and 36. 3 goes into, or 12 goes into 36 3 times, but you still end up with 180. So 36 inches per second as a unit rate is the same thing as 180 feet per minute as a unit rate. So the conversion ended up being 36 feet per minute. Okay, let's now take a look at number 2. And once again, if you didn't do this last year, you probably should take very good notes. We are converting from 10 miles per hour to feet per minute. So I like to start and finish so that it's clear which direction I'm going. I'm starting with 10 miles per hour. I'm finishing with feet per minute. So I'm converting the unit rate of 10 miles per hour into something feet per minute. So we have 2 conversions we need to do. The conversion between miles and feet, and then eventually the conversion between hours and minutes. Anybody know the conversion between feet and miles? Now I know for a fact you'll eventually do that in science, but nobody knows what it is? Yes?
is it 5,500?
It's 5,000 something. It's not 5,500.
5,326?
No?
5,280?
Very good. 5,280. So that means, let me take my writing off of here. We're either going to multiply by 5,280 feet over 1 mile or 1 mile over 5,280 feet. Now remember, we want to finish with feet. So we have to get rid of the miles and end up with feet. Quickly turn to your shoulder partner and discuss which one you're going to multiply by. You've got about 10 seconds. All right, back up front. Which one is it going to be? The first one or the second one? Just say it. The first one. Because that's the only way miles will cancel out. If you think it's the second one, miles won't cancel out. So when we do that, I quickly get rid of those units so I don't have to worry about that anymore. I'll deal with the numbers later. Now the second conversion is between hours and minutes. And we know, obviously, there are 60 minutes in 1 hour. So we're either going to multiply by 60 minutes over 1 hour or 1 hour over 60 minutes. And remember, we're starting with hours and we want to finish with minutes. So we need to get rid of hours and finish with minutes. Quickly turn to your shoulder partner. You have 10 seconds. Which one will it be? Which one is it? First one or second one? Second one. Good, because we need minutes, or excuse me, we need hours to cancel out. And you can clearly see when we're cross-canceling diagonally, which is what we can do when we're multiplying fractions, because that's really what we're doing, hours cross-cancel. Now, let's try and do some more cross-canceling here with just the numbers. Anybody see what we can do there? Yes?
5,280 and 60?
So what do you want to do? Now, you could deal with that, but I see something that's a little bit easier to deal with than that, yeah.
You can cross-cancel 60 and 10.
Yeah, 10 goes into 10 once and 60 6 times. And I don't remember what I did here. That's what I did. 10 goes into 10 once and 60 6 times. And so now you could just leave it like that for now, but then you would have to divide it out because remember, unit rate means the denominator has to be 1. So you would need to figure out what 5,280 divided by 6 is. You can't leave a unit rate like that. I'll go ahead and do the math for you on that one. That's 880 feet per minute. 5,280 divided by 6 is 880. Okay, I would like you to try number 3 all the way through. So let's take a look at number 3. We're converting from 3.5 quarts per minute to gallons per hour. We're starting with 3.5 gallons or quarts per minute, excuse me, and we're trying to finish with a unit rate of something gallons per hour. So we need to get rid of quarts and end with gallons, get rid of minutes, end with hours. Our first conversion that I'm going to do is from quarts to gallons. There are 4 quarts in 1 gallon, so that means we're either going to multiply by 4 quarts over 1 gallon or 1 gallon over 4 quarts. Since we need to get rid of quarts, obviously it should be the second one. And then I quickly get rid of my quarts so I don't have to worry about that anymore. Now we're dealing with the 2 denominators. Minutes to hours. I need to get rid of minutes and be left with hours. The conversion between minutes and hours, of course, is 60 minutes equals 1 hour. So we're either going to multiply by 60 minutes over 1 hour or 1 hour over 60 minutes. And obviously, hopefully it's obvious, it's the first one. 60 minutes over 1 hour will then allow us to cross-cancel the minutes out, and I get rid of those. And then it's just a matter of, you can multiply straight across and then divide, or you can try and do some cross-dividing. 4 and 60, that's a couple of nice numbers that you could do some cross-canceling there. 4 goes into 4 once and 60 15 times. Now you can multiply straight across, and it should be 52.5 gallons per hour. Converting from one unit rate to another. All right, any questions with this problem? Okay, last thing for today is another thing from 7th grade, and that's dealing with, and actually it's from 6th grade, dealing with these problems that we typically see. What number is this of this, or what percent of this is this, and things like that. So here's a typical example. 72 is what percent of 30? Typically, when we deal with a problem like this, we want to think of it as a proportional situation. And when we do that, we set up the proportion like this. So if you didn't recognize that original problem, now when you see this proportional situation, you should recognize that, because no matter what class you were in, you should have dealt with situations like that. Percent over 100 equals the part over the whole, or you can think of it as the is number over the of number. So in this problem, we do not know the percent, so we can use a variable there. The part, or the is number, is 72, so that would be our numerator. And the whole, or the of number, would be 30. And then from there, we just have a proportional situation where you could cross-multiply and cross-multiply using that algorithm. It might even help you on these if you try and reduce the given fraction down a little bit to make the number smaller. Sometimes that will save some time, but that's entirely up to you. But regardless, when we solve this, we should end up with 240%. And make sure if you're asked to find a percent that that's what you do. Find a percent. So we're not actually going to solve any of these. We're just going to work on the setup, because once you get the setup, the rest should be easy, because you did a ton of proportions last year. So here's what I'd like you to do. I'd like everybody to take a look at 1 through 4 in your notes and go ahead and set the proportion up that you think you would use to solve. You don't have to solve any of them. Give you about 2 minutes. Number 1, we know the percent this time, so it's going to be 15 over 100 equals, it's the part that we don't know. We don't know, once again, the part or the is number, but we do know the whole or the of number. So the setup should look something like that. And then once again, we could use the cross multiplication or the proportion algorithm to solve that by cross multiplying. Number 2, we know the percent. Once again, it's 18. This time we know the part or the is number, but we don't know the whole. Number 3, this time we don't know the percent, so we have n over 100. We know the part or the is number is 52, and the whole or the of number is 60. Setup would look like that. And then number 14, we don't know the percent, But we do know that the part or the is number is 14 and the whole or the of number is 15. Any questions? All right. We are finished